So, good morning, children. So, in the last class, we have covered overcurrent relay, but due to some technical issues, it was not delivered up to the mark. So, I want to repeat it once again here. So, again, we will start with overcurrent relay, or shortly termed as OCR. I want you guys to mark down whatever topics I am giving right now here. Fine. So, moving towards OCR. What is OCR? Overcurrent means the name itself reveals that the current is exceeding the value. The more value of current is introduced to the system. So overcurrent relay is used for protecting the devices from the excessive flow of current. Fine. So we'll move towards the working of this relay. That how does it work? See, you guys are seeing basically how the relay works on that day. What is having? It is having a current coil, and when the current coil during the normal condition, what happens? See, I'll elaborate it once again over here. Say this is the line. This is the line in which the current coil is there. During the normal condition, what happens? So the secondary of current coil is connected to the relay circuit. Fine. So during the normal condition, here the primary of the CT, the nominal current will be flowing, due to which there will not be any action of the circuit, this relay circuit. This is the relay coil. The secondary of the CT is the relay coil. So in the normal working condition, the flow of current is satisfactory or nominal, which is permissible limit to the instruments. In that case, the CT won't be energized or it won't initiate the relay coil. Fine. So when this exceeds the value, predetermined value or preset value, the relay coil is energized, which will guide the trip circuit to break the tripping element from the circuit. Fine. So first of all, to understand working, we'll be seeing that there will be a CC. CC is current coil. This is the current coil. Fine. During normal current, the magnetic effect. See, I already wrote it over here. Normal current, the magnetic effect is not sufficient to move the moving element of the relay. Means during normal working condition, what happens? The magnetic effect of the current coil is not sufficient to move the element of the relay, which is used for tripping the contacts. Fine. So in that case, I can say that you have studied about various kinds of forces in BTTT. Fine. So in this case, the restraining force is greater than deflecting force. See, point to be noted. The case when normal condition persists, in that time the restraining force is much greater than the deflecting force. That means there will be a stable operation and the moving system of the relay won't be get operated. Fine. In that case, the quality or the channel of the continuity of the supply is maintained or restrained, since the restraining force is much greater than the deflecting. Fine. So this is the normal operating current. When normal current. Third, when the current through the coil is increased, means in case the fault has taken place. At that time, what happens? This changes its position. Means restraining force is now lesser than deflecting force. Means the deflecting force will take over the restraining force and the relay is subjected to operate. Got this, children? Fine. So in that case, when current is increased, now what happens? The restraining force will get down and the deflecting force will come to action. And what does that do? The deflecting force will tend the moving element of the relay system to break the contacts from the continuity line. Fine. So, fourth one. What is this? This is moving element starts to change the contact position of the relay. So finally, what happens when these are the four working conditions? That means there will be a CC, fine, normal current, then restraining force greater than deflecting force. When current exceeds, then the deflecting force is greater than restraining force, and the fourth moving element starts to change the contact position of the relay in order to break the circuit from the healthy line. Fine. So this is the working of overcurrent relay. This is very important from examination point of view. So again, now moving towards causes of overcurrent. I believe this is clear to you, children. So now, causes of overcurrent. So what is overcurrent? Causes. First of all, there are mainly or noticeably three major causes of overcurrent. So first is excessive load. Anyway, you guys know what is excessive load, no need of any explanation. Though excessive load means the normal loading condition, permissible condition. If it is exceeded, then we'll say that it's excessive load. Likewise, there is a permissible limit of loading on each and every bus bar or on each and every line. So if you exceed that particular limit, then that comes under excessive load condition. Second is the incorrect design. What is incorrect design? Suppose if any of the likewise, if I'll give you an example, you all know the place where college is standing. So previously, 5 years back, if you move, we won't be having this much housing spaces, this mall and each and everything over here. What we are experiencing today or this date, we are experiencing many malls and shopping corners and all, and even housing sectors has also been huge number. They have been increased. So previously, what happened? There were one substation over in the Smriti Nagar, and we were not having any much housing spaces, malls, or any markets. Likewise, for risky markets, we were not having. So in that case, the transformer of that particular substation was having a limited value to handle, or a limited power to handle, or limited location to be monitored. But when the value or the power requirement has been increased or it has been raised, what they did, whether they took out all those plants which were installed years and years back and put the new one, is that? No. They have raised the design, or they have impacted more machines, more transformers. They ask the newly devisers to work in parallel in order to meet the requirements of the new area, isn't it? They didn't cancel overall design and prepare the new one overnight. It doesn't happen likewise, right? So in that case, if incorrect design is there, what happens? If any upcoming requirement is there, so that particular design won't be able to cope up with that upcoming requirement or energy requirement. Fine. So while designing any of the system, we should keep in mind that if further elaboration is needed, or if we have to extend, then it must be kept in mind, and we should construct the design likewise so that the further multiplication is possible. Fine. So this is the problem when incorrect design is there. It will cause the overcurrent to the system. So thirdly, we are having ground faults. So need not say what is ground fault because you all know it is LG, LLG, triple LG. I believe you guys knew this, isn't it? We came across these many faults in power systems, right? So all those faults which include ground, that is ground, fine. So these are the primary or main causes of overcurrent in any system. So you can note down this causes of OCR. First of all, excessive load. Excessive loading is due to incorrect or mismatching of the load. Fine. Second is incorrect design. Incorrect design is the yes, it is. It is the design which will ensure the use of limited apparatus or which won't allow you to elaborate the system. Fine. Ground fault. Ground fault is LG, LLG or triple LG fault. Those fault which will include the ground. Fine. So again, moving towards now further. Now we'll see the types of OCR. Children, I believe you are making a notebook, separate notebook for this, and you're marking the same because as soon as we meet face to face, I need all this. You better know this, right? Fine. So, depending upon type, classification depending upon time. So, the classification of OCR or overcurrent relay depending upon time. The first is instantaneous OCR, instantaneous overcurrent relay. What is instantaneous overcurrent relay? Fine. So now instantaneous name itself reveals something. Instantaneous overcurrent relay means without any time delay. Instant means at any that particular moment when I am talking. Isn't it? Without time delay. That means at time t equals to 0 seconds. At time t equals to 0 seconds. This relay will come into action. Means as soon as the problem or the fault has been created or it has been taken place, what happens? Without wasting the time at time t equals to 0 second, it will make the circuit breaker initiate to break the circuit from the healthy line. Right? So this is the instantaneous overcurrent. Second is definite time. OCR. Definite time means there is some time limit, isn't it? Definite time. So on that day when we were having our class, I told you about time setting, pre-setting time and all. Right? So what is this definite time? Definite time is the pre-setted time. So many times in many places, it is permissible that we will allow the fault current to pass through the system for some sort of seconds or 1 or the 2 cycles, which is permissible depending upon the intensity of the fault which can be withstanded by that particular area of the system. Fine. So definite time is the minimum allowable limit or the span of the time during which the system won't be operated. Means after that definite time, if the fault persists or if again the fault is there in the system beyond that definite time, again the relay will come to action in order to make the CB initiate to break the circuit. Fine. So this definite time relay, what it does, it is having one presetted time. Within that span of time, no action is taking place. Means sometimes that fault will be cleared within that span of time. That's the main cause actually. Sometimes the surge will be there. Sometimes we know that there are impulses in the line. Right? So if impulse is there, it won't be lasting for even for more than half a second, half a cycle. Impulse won't last for even half cycles sometimes. So what happens? This definite time relay does not operate for a single impulse. Right? So this definite time relay will operate only when the definite time span presetted in the relay exceeds the value. Right? The third is inverse time over current relay. Now what does this inverse time over current? This relay is having its own main advantages, especially in distribution system. Means the distribution of the transmission lines. We use these type of relay, inverse time over current relay. Why this relay? Actually, this relay is having its own advantages since this relay operates according to the intensity of the fault. Means if the fault is more, the time of operation is less. Means depending upon the fault intensity, the relay will decide when to operate. Fine. So it is having three types. That is IDMT. It is inverse definite minimum time relay. IDMT is inverse definite minimum time relay. Fine. The second is very inverse relay. And the third is extremely inverse. So, depending upon the time, three classification of relays. First is instantaneous OCR, which will operate within no time. Okay. After the occurrence of fault, that is at time t equals to 0 seconds. Second, it's definite time OCR, means there is an intentional time delay. Then if that intentional time delay, after that, if the system is having the fault or the persistence of fault is there, then it will operate. Thirdly, we are having inverse time over current relay. That means inverse time means its characteristics is inverse, means that time versus current characteristics is inverse. We are having time versus current characteristics inverse. Fine. So in this way, we are having three classifications: IDMT, very inverse, and extremely inverse. What is IDMT? IDMT is inverse definite time minimum time relay, and very inverse relay. These in fact, inverse time over current relay is having inverted characteristics. Means inverse current versus time characteristics. And in this, the IDMT is in top level. After that, we are having very inverse, which is having its characteristics below IDMT relay. And extremely inverse relay is having its characteristics again below the very inverse. Means if you see the characteristics chart, the IDMT chart is above very inverse and extremely inverse. Again, this very inverse will be in between IDMT and extremely inverse, and the lower end we are having extremely inverse relay characteristics. Fine. So you can note down this. So moving further, we'll see the characteristics. Now, what is instantaneous OCR? See, what is instantaneous OCR characteristics? Characteristic plot. See, this is time versus current. I believe you all can see in the y-axis it's time, x-axis it's current. Fine. So here there is one presetted value of current which is termed as IP, I subscript P. IP is presetted current. Fine children, there is one presetted current. What is this presetting? Relay presetting, I told you, it's a permissible amount of current which can be withstood by the system during operation. Fine? So the presetted value of tolerance, it is actually known as tolerance. Fine? So this is the presetted value of current. So if the current goes beyond this presetted value, trip. If the current is within this presetted value, no trip. I believe it is clear. Fine. So the characteristics plot is between time and current. If the current exceeds the presetted value, it will trip. And if it is within that range, there won't be any tripping action taking place. I believe it is clear. You can plot the characteristics. Fine. So again, moving further. Second, for definite time. Definite time characteristics plot. So here again, it is again between current and time. The plot is between current and time with current in y-axis and time in x-axis. See here. Here, the marking is there for a definite time. The marking is for definite time within that span of time. Here, see, I believe you all can see. This is the definite time within that span of time. No action. No trip. Beyond this, the tripping action. Means this is the characteristic. See, this is the tripping area. Within this means within that definite time value which is presetted in the instrument, there won't be any tripping action taking place. Beyond that definite time, if the current exceeds and the time exceeds, then what happens? It will go to the tripping action. Fine. So this is the definite time characteristics plot. You can again note down this. We move further. Actually, we can say that in this the intentional time delay is there. Intentional time delay. What is this? This definite time is intentional time delay. Intentionally, we used to give a time delay to the device. Fine. Moving further. So the third one was, what was that? It is inverse time. It is again inverse time. Now what does this say? This characteristics plot. I believe you can see. Again, x and y axis. Here we are having amperes. Here we are having time t. Current in ampere, time in t. Fine. In this, the characteristics is inverse. See, inverse characteristics. Look here. The characteristic is inverse. Fine. Means the current versus time characteristics is inverse in inverse time over current rate. Got this? You can note down again that. So the major advantages relate in point of view of operation for distribution line is inverse time relay. Why? Because in that the intensity or the severance of the fault, the severity of the fault is taken into account for clearing the fault. Means if the fault is more, the clearing time is less. If the fault intensity is more, the clearing time is less. Fine. So I believe it is clear. So now we'll see. I believe you all noted this. So I'll move towards the characteristics of inverse time relays. So we had seen three types of inverse time relays. So what are those? First, IDMT, very inverse and extremely inverse, isn't it? So see the plot of the same. Now, characteristics of various OCRs. So see this. Here we are having operating time in sec and 0, 1, 10 seconds, 10, 100. What is this? This is the multiples of plug setting. See, in that way in which I had given you notes about the plug setting multiplier. I will continue in the next class about this multiples of plug setting. Plug setting is there is presetted values in each and every relay which is permissible for the operation of the relay, which is beneficial. You can understand the working of each and every relay with the help of the multiples of plug setting. Means at what intensity of plug setting the relays tend to operate. You can understand that. So here in x-axis I am having multiples of plug setting and in y-axis I am having operating time in seconds. So let's say this. If I go for the relay characteristics, see, this is definite time relay. Fine. So here I am having characteristics of IDMT relay. See, this all characteristics are inverse characteristics. These are inverse relays. Fine. So this is very inverse relay, and this is extremely inverse. Can see the characteristics. There is operating time in seconds 0, 1 sec, 2, 10 sec. Plug multiplier setting means settings in terms of current, permissible amount of current. Fine. There is a definite time relay. There is a definite time span or the permissible time delay given to the relay. So that is the definite time relay. So moving, these all are inverse time relays. These are the classification of inverse time relays. In that we can say that IDMT is on top of very inverse and extremely inverse relays. Fine. So plot the characteristics. So I believe what all topics we covered today. So overcurrent relay. We are saying what is overcurrent relay? Overcurrent relay is the relay which will operate when the presetted value of the current has been increased. Fine. So with certain time span or permissible value which is allowed to that particular relay. Now, what are the types of overcurrent relay? There are three types, in which there is one is instantaneous overcurrent relay, second is definite time overcurrent relay, and the third one is inverse overcurrent relay. So in that inverse we are having IDMT, inverse definite minimum time relay, very inverse relay, and extremely inverse. These relays are used for protecting the distribution networks or the distribution lines. Fine. So extremely inverse relay, very inverse relay, these are used for extremely inverse relay is especially used for transformer and feeder busbar protection. Extremely inverse relay is used for transformer and busbar protection. Fine. So these all are jointly used for the protection of transmission lines or the distribution lines. Now, in definite time relay, there is a permissible time span or time lag given to the relay. Within that span of time, if again the problem exists, then what happens? This relay will come to action. And if the problem gets solved within that span of time, this relay won't operate. Fine. So again, this is the characteristics of various relays: definite time relay, IDMT relay, very inverse and extreme relay. There's no need of going for characteristics of overcurrent relay. Why? Because it is having its presetted value. Within that presetted value, if the fault is cleared, then it's okay, or not, then it will go to trip, where we have seen that the trip and no trip action of that instantaneous overcurrent. Fine. So I conclude this topic. I believe you are giving your attendance in the chat box, isn't it? So note down all these things, and I will be giving you PDF notes by today or tomorrow again. So note down that also according to a syllabus, whatever you are having. Fine, we will see in the next class. Thank you, class.